Find the marginal distribution and conditional distribution from a chart. Be able to statistically figure out if two things are independent. All right, so margins, you're going to have a box of some sort, okay?
Yeah.
Who knows what kind of data. Let's just say we're talking about males, females, and we're going to go with eye color. Blue eyes, maybe green eyes. What do we have? Brown eyes. We're just going to go that way. We'll lump hazel in there somewhere. And then over on the edge here, this is where you have your totals. And this then separates it. These are your margins. You take the cell, or, well, actually I would say you take like the row or column total, and you divide it by the grand total. That's going to be right there. Okay, and most of you guys have a pretty good understanding of how to do marginal distribution. Okay, conditional distribution. Right, that's going to be from the cells on the inside. And it's going to be divided by a total. Depending on how they ask the question, it might be divided by the grand total, it might be divided by a marginal total, the row or the column, either one of those two. All right. The next thing is we need to be able to statistically, or I'll pause for a second if you guys want to write that down. Then we need to statistically figure out if two things are independent. Okay? Don't forget, you will have your, I have it with me, your sheet with all your formulas on it. You are going to have that. Okay? Now, it's not going to tell you on that sheet, oh, this is how you find independence, but that's where it's going to be. It looks like this. The probability of A given B equals the probability of A. This is your test for independence. Now, do you guys remember the formula for the probability of A given B? That is basically the probability of A and B divided by the probability of B, and then that would equal the probability of A.
Okay,
Yep, go ahead.
there was a question on the review.
Okay.
Okay, so it was like, do the pie charts above indicate that milk consumption by young girls is independent of the nationwide survey year? Some of that is the first page.
Okay. And did they give you a chart? Okay, can I have your copy for a moment? Is this it? Okay, so you have this, and they wanted to know if these two were independent. This one is independent because they are the same. Okay, the areas are clearly the same, but because these two areas are not equal, independence is all about you have an equal chance of something happening. Okay, so these have an equal chance within that year that somebody consumed milk or did not consume milk. Okay, rolling a die, you always have a 1/6 chance of getting one of the numbers. flipping a coin, you always have a 50% chance of getting one of the numbers, okay? Does that make more sense? So independent's all about percentages being the same. That would be when you look at just a chart. All right. Okay, now you need to know when to use the best way to collect data. All right? A sample study. All right, this is when you choose a population. You can block it. You can put it into groups. And don't forget that for a good sample study, what are two qualities that you should have? Not necessarily, all right, a control group, yes. Can I just choose anybody I want to choose? It has to be random. That's the biggest thing, is it must be randomized. And yes, have some sort of a control. And how are typically these sort of studies done? What do they typically do? Yeah, they do a survey of some sort. Questionnaire. All right. Simulation. If they ask you to do a simulation and they give you information, you can do this on a calculator. You assign digits. You know what do you remember that? Yeah. You assign digits and then you randomly choose. You can also use the random digit table. Right. This is going to be, and you would usually use this on a small sample. Okay, I mean, if you needed to do it out of 100, that's pretty great, and you probably wouldn't do that 100 times. Okay. Experiment. What are some qualities of an experiment?
Could be like a blind and double blind.
Definitely, you could do things like you could have a blind, or you could have a double blind. The key quality of an experiment is that you're going to, and this word's kind of harsh, but it's what you do. You manipulate the subjects. I mean, manipulate, again, sounds like a really harsh word, but it could be, half these people take this sort of medicine to see if it helps with their diet, half do not. So that's what an experiment is like. You manipulate the subjects, you have factors, and if you multiply them by the levels, that tells you how many treatments you're doing. A factor is going to be something like medicine. A level would be how many different types of medicine you give out, and then that would be how many treatments. Like how many different types of maybe the medicine or whatever you're manipulating them with. All right, observational studies. What's the one that we saw the video on, and it was an observational study? No, that was probability. The what? No, that was the goats and the cars. That was the probability. That wasn't an observational study. Yep, they were the kids. What were they?
The marshmallows.
The marshmallows. That's right. And what were they trying to study?
Whether they would eat it.
Whether they would eat it, but what were they actually looking for? Their level of what? Discipline, yeah. You know, did they have, you know, and then what they did was they turned it into kind of a prospective study, because then they went and they looked at what would happen over time, and these children, you know, how successful they were later on in life. Okay? So for an observational study, you observe what's going on. This was way back in the beginning of the year that we did all of this. And you can have two types. You can have a retrospective.
Oh, I think past, right?
Yes, that's, you look into the past or you look back.
And the first time.
And it's prospective. And that is when you look to the future. And it's over time. What about a census? What's a census?
When you get the entire population.
Yep, the whole population is surveyed. Any randomization going on here?
No.
No randomization here. I think it's every 10 years they do like a population census. I do not know.
What did they?
They ask you a lot of questions. They want to know your income, they want to know your marital status, children, just background of education. They collect tons and tons of data, and then from where you live and all of that, they crunch that data and they make observations about people, or not observations, but they gather information about types of people and where they live, and yeah.
Like kind of stereotyping now?
It is. Yeah, I guess so. They kind of do a little bit, they say, well, most people that live in Leelanau County, this is their average income, and this is how many children they have, and this is their average age. The average age of Leelanau County right now, I believe, is 50.
Average age.
Yeah. There are a lot of retired people that live in this county. A lot. I know it's hard for us to imagine because we mostly just know teenagers that go to schools, but I'm sorry, maybe not Leelanau County, Sutton's Bay.
Sutton's Bay, I think.
Yeah. A lot of, this is a big, retired people.
That really skews it.
But anyways, okay, so you guys are those little,
This is old people there.
Mrs. Hersey's, moving right into that crowd. All right. Understand how to create a simulation with random digits. Basically, you guys, if you have a percent, okay, when you have a percent, you want to assign, what numbers would you assign if they said, 49% are this, and
It depends.
do you go to 100? No, we start with,
0 to 9.
and
0 to 99.
here's 0 to 99. If it's percent by tens,
Yeah.
then it's 0 to 9, okay? And you can then do it on the calculator. Do you know how to get there?
No.
All right, so we would go, you want to do rand int, and that is in math, and then you go over to probability. Okay. All right. Is that okay if I flip or not?
Yeah.
All right.
No, you can go back.
Go back for a sec, sure. How much more do we have? Wow.
Cool, thank you. Yep.
All right. Okay. Got it?
Yeah.
Okay. The next part is you need to know the pitfalls of the survey methods. Okay? So these are different biases. We actually talked about response bias last week or something. You know, someone phrasing a question. But
Which was
let's and I think me.
Mike, I think.
All right. So non-response bias. What is that? When would this occur? Yep.
Like you did a survey and, I don't know, a bunch of people did.
By mail, like if you send out a survey by mail, only the people that want to voice their opinion are heard.
Okay. Yeah. So basically, it's non-response because people do not respond. Or maybe they choose not to respond. And it's typically not an in-your-face, I don't want to take this survey type of situation. It's kind of like what Alex said. You know, you get something in the mail and you're like, you know what, I don't have time to fill out that survey. And you don't. Okay. Under coverage?
I don't remember the familiar word.
Not a lot of people will respond.
It's like when a whole,
Not a lot of people want to survey. When do you get secret survey?
Well, because it's undercover. Yeah, no. But that's a good, you know. No, under coverage is when you leave out a certain population. Okay.
Oh, they would do that during elections, like years ago, right?
Shoulders
And they still do that.
Okay. All right. Voluntary response bias.
that's when the people like that want to voice their opinion.
Yeah, they choose to respond. Yep. So basically, people who want to voice their opinion respond. Sometimes it's they have a stake in the matter. You know, they will somehow benefit by responding or voicing their opinion, and so they do. All right. And the last one is response bias.
The way it's worded.
That is correct. A question is written to elicit or influence how you respond.
I'm glad you're ready to
There you go. Add it to your vocab. Understand that association does not equal causation. Wow, is that big? Right there. Okay?
Association's not
Association does not equal. Give an example.
Storks. No, remember? It was like the ice cream thing.
Yes. Yes, that would be one. Just because you eat ice cream does not mean that the more ice cream you eat means that you are more susceptible to drowning. No, they found an association because of it, only because of that. What kind of gets in the way?
working variable.
There might be lurking variables or what other kind of variables? Well, just a minute. Maybe that's later on that I can. No, that's not in here, so we might as well address it.
Unusual.
There could be lurking variables, and there could be confounding. Okay?
What are confounding?
Confounding, well, lurking variable is when you have something hidden. Confounding is when it's right in, it's actually talked about in the study and it's there, but it's, you know, lurking means that it's hidden and it's not there. For example, with the ice cream and the drownings, the lurking variable is that it's summertime. They didn't say that it was summertime, they just talked about those two things. Confounding would be something where where it's right there and it's present and it's messing up your data. I'm trying to think of an example and I cannot right now. But it is talked about and it's right there. Could be that let's say that I had a statistics class in the morning and I had a statistics class in the afternoon, okay? And I wanted to see, by going through this, which class did better. Well, the confounding variable is one was in the morning and one was in the afternoon, and maybe the people in the morning were not quite awake yet, and so then, or on the other hand, maybe they were more awake and ready to learn versus the people in the afternoon who were ready to take a nap. Yeah, confounding is there, it is shown. Lurking is a hidden quality that we don't know about. So it's like, it's not even talked about. Do you guys understand weasel words? All right, so that's, yeah, may happen, possible, on average, according to the data, do not say this is going to happen, or do not be definitive.
Should never say that.
Not unless you're 100%, and it's pretty hard to be 100% sure. Just like I've learned, because of my age, never to say that I will never do something. Okay? The words like never, always, those are extreme words, okay, guys? Never means actually never. I'm never going to understand this. Really? Never? I mean, that's so you always want to try to use those weasel words. I find it very difficult to understand this, you know. So get a little bit better at that. Make sure that you can understand what experimental units are, factors, treatments, and response variables. Okay? So, do you remember when they did that let's say we're doing an experimental unit and we're doing an experiment on dogs. Okay? And what we want to do is we're going to put them on a diet.
Experimental units are always.
The chubby dog?
No. I'm just doing an example here.
There's something with chubby dog.
Oh yeah, remember that chubby dog one, right? And so we're going to test the diet food, or the food that you give them. The treatments are the ways you can branch off.
We're going to have to make one.
No, you would probably just have to identify. Identify what is like they'll read it to you, and then you just need to identify what is the experimental unit, what are the factors, and what are the treatments. And the response variable, guys, that is ultimately when you're reading the problem, it's what you want to change. Okay. All right. We've done these. We've done prospective study, I mentioned that. We've done retrospective, randomization, experiment. We've talked about that. We've talked about a survey. It's about gathering information. Matched pairs experiment. And what this one is you run the same experiment. Parallel with each other. Okay? So two things side by side.
What's that first word there?
Run the same experiment, yes. Okay, this is kind of a big one right here. To understand what not statistically significant means. if something's not statistically significant, what it means is what you discover, or what was discovered, could have happened naturally. Okay?
That is important.
Yes, it is. For example, I'm trying to see if kids driving to a rural school have more accidents than kids driving, on a highway or something in an urban area. Well, statistically, they found that, there's the percentage of kids that get into accidents on the way to school is 5%. And I did mine, and I found out that there was, 5%. Well, that's going to happen naturally. That doesn't mean that just because it's here that it's going to, it's just, because some things just happen in nature. Do you understand what I'm saying here? I don't know if you get this or not. Okay, sometimes people do an experiment and they say, oh, this is why. Well, no. I mean, that's just naturally what's going to happen. Anyway, so that's what not statistically means. If it was statistically significant, then it would not have happened naturally. Okay? This experiment is something that, would not have naturally happened. This needed some sort of manipulation or something. All right. Let's take a little break right now, okay? And then we'll come back. Okay.